Let's solve this function. Solving the function means to find the value of x, the possible value or values of x between this domain. We have an equation here, so we can throw the 1 over. We divide both sides by 2, so we get cosine squared x equals 1/2. Know that cosine squared x is the same thing as cosine x all squared. And we know that we can square root both sides, and so we get cosine x is equals to plus minus the square root of this entire fraction. Now recall that the square root of 1/2, if you're talking about plus minus the square root of 1/2, this is the same thing as square root of 1 over the square root of 2. And of course the square root of 1 is just 1. So we have two possibilities. Cosine x is either positive 1 over root 2 or negative 1 over root 2. Let's just take this problem 1/2 at a time. So firstly, this is your classic trig of some unknown angle is equal to some special value. And so we tack this by going haya, ASTC, and then we focus on the positive number. Cosine is positive in quadrants 1 and 4, A and C. Because the letters are the same, we know it's going to be positive here. All things are positive in quadrant 1. And cosine of what is equals to 1 over root 2? The answer is 45. So if you're rusty on this topic, look up special angles. Cosine of 45 is 1 over root 2. So the reference angle is 45, and we can find the two possible solutions between 0 and 360 by revolving, starting at 0 degrees and going all the way around to 360. And the solutions we find are 45, which is here, and 315, which is all the way around this much. This is 270 plus 45 more is 315. The second half is similar. Cosine is negative in these two quadrants, and then we don't have to worry about the sign anymore. Just focus on the value. Cosine of what is 1 over root 2, and again the reference angle is 45. So we find the possible values. The first angle, this is the third angle we're finding, the third solution is 135. And as well, 225 is another solution. This is going to be 180 plus reference angle 45 is 225. So these are the four solutions of this equation, this trig equation.